Good afternoon. Welcome to the Think2Think Research Group interim meeting. We are probably going to wait a couple more minutes while people are joining. So I don't have to say who I am because Meet Echo tells you who I am.
And in case anyone wants to do an audio check, now is a good time.
Hello, Ari.
Thank you. Mine seems to be working.
Hello, Ari, Karsten, everyone.
Hello.
Alex.
I just learned if you use the change deck button and you don't select a new slide deck, then your presentation will be ended. That's interesting. Okay, I think the joining is slowing down, so maybe I can start doing the administrative part of the chair slide. So welcome again to the June interim of the Think2Think Research Group. I'm Carsten Burmann, and Ari also has joined and has already said hello. So let me quickly go through the preliminaries. We have a custom-made Note-Well slide, which is not endorsed by our lawyers, but contains the main points. You will be recorded. At some point, I need to fix this slide. It says you may be recorded. You will be recorded. We all try to be nice to each other, and we also try to abide by the IPR guidelines essentially of the IETF. We have a separate page that special cases this for the IETF, but the guidelines are essentially the same. This is the short form, and the long form is that you will be recorded, and there is a code of conduct that we want to follow. And this is not theoretical right now. Something is going on the IETF list again. It's incredible. Intellectual property is Alex, you should be hearing me.
Hello, yes.
Hello, Javier. So if you know about, okay, there's another audio problem.
Seems to be working fine for me.
Yeah.
Yes, I had
Yeah, me too. It's working.
I had to restart my web page and it worked.
Okay. You are quite quiet at the moment, just for your information. Okay, so has Elliot restarted yet? I'm not seeing Elliot at all. Yeah, one of the nice things about Macs is that they sometimes decide to use a different audio input. You usually have several audio inputs to choose from, and it sometimes decides to use a different one from the one you are thinking you are using. and then sometimes the level also isn't right. Anyway, so the intellectual property rules include the main point that if you want to talk about technology and you know about patent claims that apply to this technology, then you have to tell us in the form of a formal IPR disclosure. Details are on the web pages here. IETFers know that, but I'm just saying this because there may be non-IETFers in this meeting. Of course, you can always choose not to talk about the encumbered technology, but if you want to talk about it, you have to tell us. Okay, so these were the official Notewell slides, the legally required ones. Now let me just quickly remind people, we are going to talk about technology here that has been standardized, or that is being standardized, or that we may want to get standardized. But the actual standardization is not going to happen in the IRTF, because the IRTF is focusing on the research issues behind those technologies. And the IETF then goes on doing standardization. So sometimes we just hand over topics to the IETF, sometimes we get working groups started in the IETF based on research that happened in the IRTF. But you have to keep in mind what people are talking about here is not necessarily what they or anybody else want to standardize next week. And there is a nice RC 7418 that explains a little bit more. We have notes. Please join the note takers. There is at the top of the screen there is a piece of paper with a pen on it that gives you the notes page, and there you can open that as a separate window. Unfortunately, you cannot click the link that is on this page. We have a chat, which you can enable by pressing the two bubbles, the two speaking bubbles at the top of your page, or you can separately run this using this Zulip link, or using the link that, or you can get at the notes using the link that Ari just put into the chat. There is a mailing list that you may want to subscribe to if you are not subscribed there, and I'm sure this link is now wrong because we just converted to a new version of Mailman, but I hope there will be a forward. And there is a repository, a Git repository, traditionally on GitHub, that has various information and eventually the slides, but you can get at the slides from the agenda that is referenced by this repository README. Okay, so what is the Thing2Thing research group? The idea is that we have been standardizing IoT-related technologies for almost 20 years now. Well, we have been standardizing a lot of them before, but specifically with IoT in mind since 2005. And sometime, oh, yeah, that's bad if people are dropping out due to losing audio. Yeah, a quick reload is usually a bit ugly, but can solve the problem. So we have been doing IT-related standardization for 2 decades now, and after we had the first set of standards in place, we found there are a few things that are not trivial and require research, and that's when we started the Thing2Thing research group. And the objective is to be able to have an internet of people, of services, but also of things that includes low resource nodes, because the Internet of Things will be big and we will have many nodes. And we want to enable those low resource nodes, little power, bad connection, intermittent operation, and so on. We want to enable these nodes to actually be useful citizens of the internet. So that's our research objective. And that sometimes means that we take existing protocols and just tweak them a little bit to be better for low resource nodes. Or sometimes we actually standardize new things in the IETF to support these. And the research group focuses on issues that might have opportunities for IETF standardization, again, without implying standardization already right here. And we do this full stack. So we, well, not the radio layer, but a part above the radio layer. I think we will even have a talk today that talks about the radio layer up to user experience, security functions, and so on. So this meeting is started as an overflow meeting from the really nice physical meeting we had in Paris. But it quickly focused on the various ways we are using CoreConf. We are using Yang modeled data to do management and other things in the IoT. And we will get 2 talks about interfacing to the Yang models from constrained devices. And I hope 3 talks. I'm not seeing Fabian yet about using CoreConf in the real world. And because he got so many CoreConf talks, I decided to push my talk to the next meeting, because we are going to have a next meeting late June, early July. There will be a Doodle, or we are not using Doodle anymore, a rally page where you can indicate your preference soon. And this will probably return to the subject of security, which was the main subject in Paris in the physical meeting, and maybe we will have time to actually do my talk as well. One thing that's obviously of interest is, are we going to have more physical meetings? As I said, we had a really nice face-to-face interim meeting organized by INRIA and what was it? Open, an organization that the name of which starts with open, sorry. That was organized in Paris, and it was really good. There was some 40 people there for the hackathon, which gave us a nice basis to draw from in a research group meeting. And we certainly want to have more interim meetings, more physical meetings. We're not going to use the opportunity to have one in Vancouver, because it turns out a lot of the people interested in this are not coming to Vancouver, which is a little bit surprising. And what we definitely will try to make use of is the physical meeting after that, the Dublin IETF. And we still have to decide how exactly we are going to use this opportunity. Are we going to meet within the week? Are we going to have a pre-meeting? Are we going to have both? So that discussion will probably go on in the next couple of months. So that's definitely going to happen. And then, of course, we have to think about the next couple of IETFs, like Bangkok in February next year and Madrid in July next year. And of course, the interesting question is, are we going to have any other ones of those? Okay, so sorry for taking 5 minutes too many for this intro. So we are done with the introduction. Are there any questions about that? I'm not hearing any questions, so I can push those slides to Laurent.
Okay, hello. You hear me?
Yes,
Okay, perfect.
and you have control.
Okay, thank you. So yes, I wanted to talk about something we have developed a few time ago about what we call seed extension, because it is viewed right now as an extension to the seed file that we generate with Pyong. And the goal is to add some information that are very useful to manipulate young data model. So just to give a little bit, a few words about the context, is that when we are CoreConf, usually, or in IoT, we have a device that is very restricted, and we have what I represent as a cloud. It's a computer that have maybe more power. The question is, so we have Yang. Yang is a very nice language. We have tools like Pyong to manipulate this language, but it's not constrained. In fact, you need a lot of line of code to do it. So on a constrained device, it can be difficult to implement, and on other system where maybe you have more room, maybe it's good also not to put all the complexity of Yang in this implementation. So what we have done, it's a tool that helps to manipulate Yang data model and give only the information we need to manipulate it. To give an example, and it's something that is quite funny, is that when you look a serialization in CBOR or JSON, you have exactly the same structure. You have map where you have object, you have dictionary. So it's exactly the same structure, but the values are totally different, or maybe different. For example, when you have an integer in Yang, in JSON you have a number, and in CBOR you can have positive or negative integer. But when you have an integer, you're not sure that it's an integer in Yang. For example, if you have identity ref or enumeration, it is represented in CBOR also as an integer, but when you go to JSON, is viewed as a string. Same thing when you have a string, it can be a string in Yang and represented as a string in CBOR, but a string can be an identity ref or an enumeration. So the type you have in the structure don't tell you how to manipulate it, and the only way to know how to manipulate it correctly is to refer to the Yang data model. And it's not easy to parse. We have Pyong that do it, but what we have installed in our seed extension, so it's some line of code that I'll add some information to the existing seed extension. So I have represented it here. So we have add a key that is called type, and type tells you what is the type of the leaf you are using. For example, in the second one, you have identity ref. For the fourth one, you have integer. And for the last one, for example, you have an enum, and you have the mapping between the integer and the string. And if you have no type in the definition, it means that this node is not a leaf, but it's an intermediary node in the Yang tree. So with this, we are able to convert a JSON structure into a CBOR structure, or vice versa. In OpenChick, for example, we use that because OpenChick manipulate only CoreConf representation, and we can manipulate rules in Chick and add or remove things. But in CoreConf, we have absolutely no tools to verify if the syntax representation is correct. So we have to do the transformation to JSON and then use a tool in OpenChick. We use Yangson to make the validation. So internally, we manipulate in CBOR, and when we want to do a manipulation, we transform it into JSON to check it. So we can do it automatically, and it's not really depending on the model. It's just using these information that are stored in the seed extension. Another thing that we can do with the seed extension, and I think it's more important for very constrained devices, is that when you have a young tree, it's quite easy to browse. It's almost always the same structure. So you have key, you have maps, and you have dictionary. But in fact, when you go to a young list, then you have to know the key, how many keys you need, and which leaves, which seeds are used as a key. And this is not present in the original seed file. And so we add also another extension that is another entry that is called key mapping. And key mapping contain an object where the key is the seed, and then you have an array with all the index, all the keys that are used in the young data model. So having this information, you are able to browse any core conf representation to find an information. For example, on syntax, here you have a dictionary where you have first the seed you are looking for, and then you have a list of keys that allow you to get to that seed. And so with so when you go through a list, how many keys do you need to go into that list? It's not present in the core conf representation. It's present in the young data model, but young data model is complex. Here, by looking at this information, you know that 60,007 is a list. This list has a single key that is represented by the seed 60,008. And this way, you can do a browsing of any young tree without needing to have the young representation. And so this is something that is quite useful in constraint environment. So to do that, we had to generate some codes. So the first is a seed extension. So it's a modification to the Pyong that allow you to have a new option that when you generate a seed, you add seed extension, and it adds this information I showed before. And we have two tools that use this information. The first one is PyCoreConf that has been written by Javier, who can say a few words if you want, but it's in this GitHub. And we have the CCoreConf, so I will not spend too much time to explain because Manoj will talk just after about this. Just to give you an idea of one thing that is currently what we have to do is, I told you that we can browse a young tree without any problem, and it's very agnostic if you have the key mapping object. But we have two types, in fact, of leaves in a young tree. You have leaves that are internal. It means that contain a value that is stored internally. For example, an index, or in Chic rule is something that is stored totally internally. But you have also leaves that maybe have a relation with outside, what we call external leaves. And for example, when you have to read a temperature or something like this, and so you have to link this value to a function that return some numbers. And to do that, we Manoj generate a program that write C code and makes the link between. So you just have then to fill some information. But Manoj will talk better about that, so I will skip this part. So in conclusion, so what we can say about CoreConf is that it's magic because it's a very, very powerful tool. You just have to create a data model in Young and ask for seeds. And once you've got that, you create automatically an efficient protocol to communicate between objects, because we are using CoAP and then CoreConf, which is very compact, and we can either use Chic to compress it. And the second thing is that on the object, we have some runit cog that is very generic. We don't, it can be, you can work for any kind of young data model. The only thing that we have to do, it's if you have interaction with outside, to link and make some call to function when needed. The other thing we also discover with Manoj, and we have no time really to explore it, but since we are in the research group, we can talk about that, is that Manoj, during his project, made a young representation on SNML. And if you look at the representation of this young data model in CBOR, it's very, very close to a CoreConf structure. And in fact, if we select correctly the seeds value, then we can find the keys as they are using in SNML coded in CBOR for the keys. So it's something that we have to investigate in more details, but it seemed very funny to see that we can make the link between SNLM and CoreConf. So what is missing and things that we can do research on it? The first one is something very simple, but it's more about standardization. How we can, if we can, in the young data model, say that a leaf is internal or external, it will ease the generation of the C code, because here we will just generate a function for external and not internal. Right now in the code, we have to list which seeds are internal and which are external. And the last point that for me can be interesting, I'm not a specialist of that, and I have a colleague that knows better this, but each time I want to talk with him, he runs away. So I will ask the group if it's a good idea or not. But I think that it could be interesting to have some to put seed in RDF, to have some semantic webs where, for example, so the question is, when you receive a CoreConf, how to understand a seed value and what you can do with it. So if we put in RDF that this seed value has this property, then it can go to the knowledge graph, and maybe we can this way process automatically the information coming from the device without before knowing what this device will be sending. So I don't know if it's a good idea or not, but I think it could be interesting to focus on that. Okay, and that was my last slide. If you have questions. Yes, Javier?
Yeah, just as a support statement. Sorry, do you hear me well? Hi, everyone.
Yeah.
Okay. Yeah, just a support statement about the seed extension functionality in Pyang. It was actually really key to properly make the conversions to and from the CBOR structure. And in fact, it's what we've been using in PyCoreConf. And it's what Rafa has been using and we developed together. So yeah, it was super good. And eventually the C implementation was also based on it. So yeah, it's been sticking around ever since, and it's very good to have.
Carsten?
Thank you. Yeah, I think this is really very interesting. If we just look back like 60 years ago, people were starting to do models of grammars, something we call BNF now, because that was the dominating result. And then people started to do code generators that generated code from those grammars. And I think most of us have worked with a parser generator like Yak or Bison at some point during their lives. What is interesting about these code generators is they are actually not only code generators. Usually they generate tables with numbers in them that really are pointers that allow you to navigate the structure that is being passed. So most of the output is actually a table, and then there is actually code that interprets this table. Now, why do I find this separation interesting? I mean, it looks like an implementation detail at first look. But one of the nice things about those tables is that they might be, depending on how exactly you structure this code generator, they might be much easier to replace and update. So you might be able to ship a new table to a device that otherwise would need a full firmware update to actually accept new code. So I think that separating the code generation into those two areas may be a useful thing to make it easier to actually avoid needing to do firmware upgrades, or actually making nodes adapt more dynamically to what other nodes they're actually talking to. So that's just a point I would like to make, which is maybe on the implementation side. I see that Christian had a comment in the chat that RDF mapping is interesting to him, and clearly we have something called Coral that we are working on in the core working group that has a strong link to RDF. So that's maybe one thing we want to look at. I found the reference to CNML very interesting because CNML right now does not have a well-defined model for mapping to RDF, but we could work on that one as well. Christian, do you want to say something about your RDF interest?
Nothing that you haven't said already.
Okay.
Alex?
Yes. Do you hear me well now? Is it okay?
Yes.
Okay, good. So I found it. Yes. So thank you very much, Laurent. And yes, I think it's a really like very exciting work. I remember in one of the past Wishy workshops, at some point there was this interrupt between the the Web of Things, so the thing description, and that time it was Evo that did some interrupt, where we actually were interrupting between CoreConf and represented the thing in the Web of Things as a Web of Things. So, and we did that through this mapping to an RDF file, I think. So I mean, it worked, and I think it was not like a huge effort. So I think that could be I would not say a low hanging fruit, but maybe not a very complicated one. So so yeah, I found that really interesting. And maybe I'll ping him to see if he has something in mind, you know, if he has written something on that point since then.
Okay, so what could be next? So we have issued this draft for T2T. We have this implementation. I don't know now if it's. I don't think it's totally synchronized with Pyang. So, do you see any way to push this work forward?
Well, I don't know who you is, but since
Everybody.
I put in some hacks into Pyang to actually do the SID file generation in a standards conforming way, and it probably makes a lot of sense to make sure that the approaches we have here, the one that just implements the standard, and the one that is an interesting but not yet standardized extension. We want to make sure that this works together. So I think we should coordinate that.
Yeah, because one point is that the seed extension is defined by a young data model, and the extension we did are not covered by this young data model. And I'm not sure, for example, that the enum will be a correct representation. So here it's just a hack to prove that is feasible, but so maybe we can go and try to add this to the young data model defined for seed.
So one interesting question here is what is being done here? The assignment of SIDs to the Yang names can be fully automated, but sometimes it's not. Sometimes you actually want to influence it. And that gives SID files a special status because they are kind of automatically generated, but they also may reflect some decisions that are not recorded anywhere else. And I think that your type and key extensions actually are fully automatically generated, or am I wrong with that?
Yes, totally, yes.
Yeah, so the question is whether it's actually a smart idea to put it into the SID file, which has this weird double life of being automatically generated, but then also influenced. And so it's kind of a precious file. It's not a file that you just throw away and then completely regenerate, because you need to record the existing mappings. So I'm not sure whether it makes sense to actually have both in one file. We may actually want to have a separate file for collecting this kind of information.
That could be a possibility, but after that, maybe it's you can have, if you have two files, are you sure that you are using the right file with the other? That's also a problem. So we have to be sure that we have the good seeds on each. So to have in a single one, we're sure. Maybe so. That's a good question.
Manoj?
Yeah, thank you for the presentation, Lohan. I think you set me up very well for my presentation. So I had comments about the SID file itself. Can we actually describe SID file in CoreConf itself, right? Because there is no reason we have to use JSON specifically. And there are some other improvements as well in formalizing SID grammar itself. So I don't know which is the correct platform to share those. Is it this one, the other one?
So the SID file is currently described by Yang model.
Okay.
So I think we already have what you are talking about. Alex?
Understood.
No, yes, I I agree with you on this, Carson. So yes, Manoj, that's actually an excellent question, and the point is that we want to be as little as less intrusive as possible in terms of what is already used at the IETF, and we've already we use the Yang we use the Yang definition of the structure, right? So probably there are other ways that could be more popular outside of the IETF, but as long as we're writing RFCs, like that's the way of least resistance, and it works.
Okay, understood. Thank you.
Yeah. And I wanted to just to add one other thing. So Laurent, when you're talking about the extensions and adding to the SID file, and when Karsten then very interestingly said that like SID files in that aspect are very precious because they are that there might be some information that is not captured anywhere else. So probably one thing about this extension, SID extension, is to see what like is there a use case where you can like I can imagine if you have the Yang file, and if you have the SID file, probably you can have a tool that can generate you the metadata, like the SID extension that you're saying here. So is there like a use case where you have only the SID file and you don't have the Yang file, where that SID extension would be?
So that's the case. Normally, the SID extension that you add to the SID file is here to avoid to have the Young data model. So, and you have information. So if you look at this SID, for example, you have an identity ref. So when you look at value 60,006, then you take a number on this SID, and you know if you want to convert it in JSON that you have to loop back in your SID extension to find the ASCII string of your identity ref. So it's information that are already stored in this file.
Mm-hmm. Okay, yeah, but I mean, probably one thing to do on the next release of the document is like to say, okay, what are the cases where you can only have this SID file?
It's the case. The goal is to avoid to have the Young data model. So once you have generated V6 extension, you are able to move from CBOR to JSON, and with key mapping, you can browse any Young data model, any score conf representation.
Okay, thank you. I mean, we'll discuss that a little bit later, but I think it helps a lot in many cases, but really need to, you know, to write it down or read it.
Yeah, we have to be a bit careful with the time right now. Alex, you said you need to leave at 5 Central European time.
Yes.
So probably we should be switching to your talk now. Let me activate those slides.
Okay. Thank you very much. So yes, I will try to be a little bit to be brief as much as I can. So thank you, Karsten and Ari, for organizing and for everyone here being like discussing the CoreConf cluster. So Laurent did like a very interesting overview with something that's really working. And I wanted just to share a small point on the SIT registries. Actually, it's quite a lot linked to the draft IETF core SID, which is in its 24th version today, and hopefully soon we'll go to the RFC editor.
But it is in the RFC editor queue, so it should be emerging from that any minute now. I finally got another document out of the RFC editor queue a couple of weeks ago, so I expect this to come any day now. It's an approved document, just needs to do the RFC editing, so consider it done.
Okay. Oh, okay. Well, that's okay. I'm putting a champagne in the fridge now for that. So that's great news. And actually, it was like a long work to actually get it done, because there are a lot of considerations going into and a lot of discussions. And I just want to get back like just a couple of mini points so that we are all on the same page. So the first thing is that when we started working, and like when the work of doing CoreConf, which is like NetConf, you know, like but with co-op and blah blah, but CoreConf with CBOR encoding, so Yang to CBOR, we actually did a lot of work on specifying how do you actually map, how do you represent the Yang data into CBOR. And it turned out that because previously NetConf and ResConf were using XML and JSON, actually they were very tolerant to ambiguity. So you really need to have the Yang file to be able to understand what the data is coming. Like you have a string, and that string can represent lots of stuff, right? And you need the Yang file the Yang model to know if it's a date time or something else. And we had a lot of work. We did a lot of work to actually really formally identify how do you represent that in CBOR. And that was one of the things that was a big work, big part of the work. And then the second one was to actually, because in the netconf and the restconf world, you have these very long identifiers. So where you actually need to say what is the thing, what is the item, what are you referring to, from where do you get data, and there are all these kind of very long strings. So you can see like in the examples, like /IETF -system dot set. I mean, it's like full with very long identifiers like that. And that was one of the first things that we said, okay, well, that's too long. No, you're just going to have like huge CBOR files because of these identifiers. And this is where we had a lot of work and discussion on how do we make it like assign a number. So how we make that more compact. So the solution we found in the end was the Yang schema item identifier, or Yang SID. So it's like it's a 63-bit unsigned integer, and one such SID identifies a Yang name. So here, that's also one interesting thing, but because we actually had to define what that is, and that was not an easy job. And thank you, Karsten, also, and Michael for participating heavily in that. Because there are a lot of things in a Yang module, and no one else had to define that, I think, before we did that. So we have the list of what a Yang name is, and then what we end up with is to have this system of allocation where you allocate, you assign one number which will be globally unique to this name. So one number maps to exactly one one number maps only to exactly one Yang name. So if you have the number, you can find the name. And then, ideally, in a perfect world, one Yang name should map to one SID. But that's not a strong requirement. No. So what I just want, I'm going just to talk about the registries here, SID registries, right? And so here are just two examples, of two SIDs that are allocated to different Yang SIDs. So two SIDs numbers to different Yang items, and you see they're 2 byte identifiers that map to a very, very long string. So it's really efficient. And the nice thing is that you can have this delta encoding. So if you have it's an intro to core SID. Yes, Michael is starting to getting sweaty. Don't worry, no, it's core SID. And so you have this really nice property that where you have multiple SIDs, you can actually only send the delta over the air, so it can really be super efficient. Now the point is, in order to guarantee this mapping, we needed to put to create a registration system that would guarantee the properties that we want from these SID numbers, their uniqueness. So in order for that to be scalable and actually to be able to be used, we allocate SIDs in ranges. So that's what we call the SID range, right? We're not going to be allocating individual SID numbers. And for scalability in the system, there actually we divided the whole 63-bit space in blocks of 1 million SIDs, and each of these 1 million SIDs is called a SID mega range, and it will be managed by SID mega range registrar. Okay. Now this is what exists. It's there in the draft. Now the point is, okay, here are a couple of terms, okay, how do we actually assign the SIDs to individual modules? So there are a couple of terms. The first thing is everything starts from the owner of a Yang module or the module controller. It's if you are the developer of the Yang module, that's probably you're the module controller. But maybe like down the road, like someone else is got ownership in somehow of the Yang module, and they control how that evolves. Right? And then, so this is one concept to keep in mind. And then you have like the SID user. So these are like definitions generally taken from the draft. Like you have the SID users. So these are like the developers or the software that are using the Yang modules and their associated SIDs. And these SID users, they need to take the SID files from a repository, for example. And that repository will provide the SID assignments. The assignment of the SID starts with the SID assigner, which is going to be assigning the SIDs, the individual numbers to the module. So that typically will be the developer of the module. And also in the system, you have the registries of the big SID ranges. Now, if everything is very confused in your head, that's normal. And I hope that it will get a little bit more clearer when I talk about this. As a developer, like a Yang developer or a controller, so the entity that is of control of the Yang module can be of three types. The first one is like SID guiding. So that means the developer knows what SIDs are and wants to like actively participate in the allocation of the SIDs. So basically they will know, like they develop their Yang module, they will know where to go to request a SID range, and they will allocate choose the SIDs for the different items in the module, and they will publish that. So they're very actively participating. We have then type 2, SID oblivious. So that means that Yang developer, like they don't know about SIDs, or they don't care about SIDs, or both, right? And typically that's like for existing Yang modules. So there are a lot of Yang modules out there. Obviously they work without having SID files, right? So at some point we need to handle that. And the third type is SID aware. So that means like, well, they know what the developer, they know what the SID are, and they know that there exists, but they don't want to bother with like assignment or stuff. So they just choose an assigner, SID assigner, and say, well, handle that for me, and like let everybody be happy. So now, like, this is like a very high-level intro to that overview. And one of the things, and I'm actually quite impressed and and very excited when I saw that, is that they actually so let Can Designer be a working group. Let's go. So maybe it's not the exact term, but let's me give you the examples, and then we discuss that, right? So the point is that the registries have already been created. So because the draft is like in the RFC editor queue, and soon it will be on RFC, so it already went through Ayana, and Ayana already created the registries that we requested in that draft. So there are the three types of registries that exists. So the first one is the Yang SID mega range. The second one is the IETF Yang SID range, and the third is IETF Yang SID. So, okay, that's a mouthful. And let me just show you the contents of the already existing registries. So the Yang SID mega range, basically this is where I said that the universe of the SID numbers, so it's like a 63-bit universe, it's a huge universe of numbers, and it's divided in chunks of one, like in big blocks of 1 million SIDs. So the first million is given to the IETF. And the organization that actually is handled that is Ayana. So Ayana is managing the first 1 million SIDs, and how this first million is distributed among the different Yang modules. Now here the point is that in the future there will be other organizations. So let's say IEEE can request to have like the second million, like from 1 million to 1 million to 2 million, to 1,999,999 and so forth. then you can have through GPP, then you have companies and so forth. So that is a first place that exists. Can a working group ask for a mega range? I think it should be silly since we already have access to any range. Okay, so I think that's Michael trying to respond to Laurent. Okay. Now the second point is, so this is the so here we have okay, IANA manages the first million on behalf of the IETF, right? And this is that range. So that is the IETF Yang seed range. So this is the first million managed by IANA, and you can see here because IANA has their rules of how things can be managed, starting from seed 0. So the first 1,000 require ISG approval. Then starting from 1,000, so seed 1,000 up to seed 60,000, you have an RFC required. So that means that these here you can have seeds only if you have an RFC. 60,000 to so starting at 60,000 and with a size of 40,000 seeds. So this is reserved for experimental private use. And then we have from 100,000 to size of 200,000, it's RFC required, and then we have 700,000 reserved. And we already have the first seed ranges that were allocated, right? You the 0 entry point 0 is reserved, it's not a valid seed. Then you have from 1,000 to 1,100 for IETF core conf, from 1,100, so 5 to 1,150, we have IETF Yang types, and so forth and so forth. So this is already allocated, right? And now the final range, so the final registry that is already out there, right, and which we'll need to populate, is the actual seed files, right? So here, basically, in the Yang seed range, we say, for example, well, the range for IETF core conf is from 1,000 with size of 100, right? And this is the draft that corresponds to it. But where's the seed file that actually gives us the exact allocation? Okay, that this Yang name, it's that's the corresponding seed. Well, we have to find that on this page, right? Here we need to have name of the module, IETF core conf, Yang file. So here a link to the Yang file, seed file, a link to the seed file, size, and reference. So the reference is going to be again the RFC or the draft, and so that will be then handled by IANA. So we'll need to populate, at least for the modules that are defined here. We'll need to generate all the seed files and communicate them to IANA. It will go through an expert review. So I hope that will be enough expert to review that sufficiently fast. And that's it. The system is bootstrapped, and we start work, right? And that's it from my talk. I just wanted to say that it's all there. Everything is out there, and I'm actually quite excited about that. Yes, Carsten.
Thank you. So this was a good overview, and I'm seeing some interesting questions in the chat that indicate that maybe some of these things were too obvious to us when we wrote the documents. But let me point out that there are two important gating points we still have to take. One is we have to find those experts. So every IANA registry has a small group of designated experts, and these experts usually look at a registration at a time. However, the initial designated experts for the SID registry will probably look at the 200 modules that IANA already has registered for RFCs. So we want to make sure that we actually have SIDs defined for all those 200 modules. And this essentially means we have to get our software into shape that it can do those SID assignments without hiccups. And then there are 750 modules in the Internet Draft space that we actually have to look at. So that's gating function number one. Gating function number two is we actually have to get those mega ranges out. And one important customer you already mentioned, which is IEEE, so that there are some people in IEEE who understand that they have to get a mega range. And yeah, we have to get the expert in place, so they do that. But of course, it will be interesting to see whether other large players like vendors get their mega ranges. So Cisco and Huawei and Juniper and so on, these should be going out and getting the mega ranges. It doesn't cost them anything beyond filling in the form. But of course, there is a certain commitment of handling the space handed to you in a well-defined way. So they will want to make sure they have it somewhere in their organization that is not destroyed by the next reorganization and things like that. So these are the two gating points I think we need to take. Let me just make one more point here. There's another large linear space that surprised people when it started to exist, and that's the Unicode character space. Now, it's much harder to get a Unicode character than it will be to get a SID assigned. But I think the principle is the same. There is a certain amount of money, of investment that goes into assigning a Unicode character. And that means there is 1 million of those available, slightly more than 1 million. And the fact that it probably takes approximately $10,000 or so to get a Unicode character assigned with all the bureaucracy and the draft writing and so on and so on. This means we can be pretty sure that we will never run out of Unicode characters, because people will not invest $10 billion into Unicode characters. That's not going to happen. The space for SIDs is incredibly much larger. So even 32-bit SIDs are a few billions. Of course, we have said 32-bit IP addresses will never run out, so we even have more SID space. But the same kind of argument can be made, even if SIDs are assigned in a pretty automatic way, until somebody comes up with a way to write new Yang specifications, new Yang models in a machine-generated way. It's very unlikely that we will ever have enough money on the table to exhaust the SID space. Of course, there are good SIDs, the shorter ones, and bad SIDs, the longer ones. But the whole thing still is an order of magnitude better than writing those Yang names in longhand. So that was the innovation. People didn't believe we could do that. So I remember core working group meetings where people who were used to the ASN1 ARC system said they'd rather have the ARC system than a single linear space, but then we couldn't have our efficient data coding. So yeah, but we still have to do these two. We have to reach those two gating points, and then we can say the whole thing is a success.
Yeah, yes, so exactly, and thank you very much, Karsten, for that. And yes, it is a very exciting time. Probably one thing, and I was thinking about that, is so it's no problem to generate like the SID files for the existing Yang modules. Probably we'll need to give a heads up to the netmod, or I don't know which working group, just to say, hey, well, we put all the files in a GitHub, so their assignment is not final. So go take yes, go take a look at that, and like if you have any comments, so like do that now, and we'll commit everything by IETF Dublin, let's say. Right. So that's one thing. And I mean, there are many other things, but I think I'll stop here. But yes, I almost cried when I saw the registries. It's like, oh my god, what was that? so yeah, thank you very much, Karsten, for and Michael for for making sure that we get to here.
Yeah, I would agree with the objective to have at least the 200 RFC modules in the ANI registry by Dublin. I think that's something we really need to do.
Laurent?
Yes, I have two questions, or one remark on one question. The question is, so it's, I sent the link on the chat, but for example, if we look at CHIC, we have a main young data model that define what we did at the beginning, and now we have some augmentation of this young data model by RFC that will define only one or two seeds for this augmentation. And if we follow the process we have right now, it means that each RFC owner has to request for seeds. And so we will have seeds that will be spread away, which is maybe bad in the sense that we have delta encoding. And so if we want something constrained, and if we don't take care about the delta encoding, then we'll have a larger representation. So from my point of view, it could be important for things like CHIC, where we have a lot of things that are done by the working group, is that it's a working group that manage the seed allocation. So get a range from IETF or IANA, and then manage the seed allocation by itself. So that was my remark. And my question is, how do we do the ISG allocation? So there is some value that are very small, like less than 1,000. So who is managing that?
Well, the ISG. So, in the end, of course, the expert, the designated expert, will play an important role. So if you remember port numbers used to have a special range, the range below 1024. And there was a designated expert making sure that this space didn't get exhausted. So that's really what the designated expert does. And of course, if the designated expert is unreasonable, then it's the ISG jobs to find a better one. But I think we need to do a little bit of consensus building on designated expert guidance that we agree is good guidance. And of course, we can always revise that, put it on a wiki page or whatever. But that will happen within the next 18 months or so. We will start to understand more of those details. So if you think you have a good use for the low SID numbers, please make your case.
Okay.
Yes, and yeah, exactly. And one thing, so because Laurent, I know that you're thinking a lot about the CHIC, CHIC sits and how to optimize the delta encoding. So I would suppose that a reasonable expert, so first of all, you have already the range for the module, and basically you make the allocation on your own. And a reasonable expert, when you submit the request to, for the exact SID number allocation, you send with that your manually made allocation. So a reasonable expert would not reject that. They will not just say, hey, well, I'm just generating everything from scratch. The reasonable expert can tell you, hey, there are two SID that are violating the rules because they are it's not a valid SID file or something else. But as long as you, as an Yang module author, you're careful about your SIDs and you're making you're fine tuning them and that, well, I don't think why anyone would say no on that.
Okay, so 10 about 1,000 is reasonable.
Sorry, what? But you want you want in the first 1,000?
Yes.
Oh, sorry about that. No. let me spare you some time on that. Okay. So thank you. I really need to go, guys. Thank you very much. I'm really sorry. Thank you very much, Karsten.
Thank you for bringing this up, Alex. I think there's a lot of work required here, so that's good that you bring this up.
Yeah, sure. Thank you.
Okay, I think we had a good discussion, but we also slightly overused our time budget. So the next. Oh, that's interesting. How do I get the slide control back from somebody who's no longer there? That's an interesting feature of the. It's gone. Okay. Yeah. So the next one on the agenda is Rafa with Yang data model for SDN based, and I'm trying to bring up your slides if you don't mind, so you can start talking.
Okay. Okay, so
So you have control?
yes, I have control now. Thank you so much. So so thank you for this slot to present our idea about using Yang data model for key management for a dog and OSCORE. We actually wrote a draft some time ago. So in these slides, we describe again let's say the architecture and a little bit about what we have been done during the recent months. So basically, the idea is that the software-defined networking as a general topic is an architecture that allows users to program, orchestrate, control, and manage network resources. And this model is being used in IoT networks, at least in the research part. And it turns out that we had previous work to manage IKE and IPsec with SDN, defining a Yang data model, and you can see there the RFC. So we thought that it could be possible to do the same thing or similar thing with HEDOC and OSCORE. So the general goal is actually providing a centralized system for the management of M2M security association between different things using Yang and conf. Obviously, potentially it's also possible just to configure one thing and then to configure using a different protocol like netconf or resconf and non-constrained device. But here in the slides, we present that thing-to-thing communication. So the steps we conceive for this architecture actually are two. First of all, the assumption is the thing is registered through some kind of bootstrapping or onboarding process in the SDN controller. And as a consequence of that, the SDN controller knows about the thing and knows it's authenticated, and they can establish a security association between them. And from that point, the second step, actually, the controller sends configuration information about ad hoc or OSCORE and to the things through the core conf and Yang data model we have defined in the draft. So regarding the first step, just a few comments because it's not, let's say, part of the idea. As I said, our assumption is that the thing is registered in the controller, and there is a security association established between them that allows to protect the information that is sent from the controller to the thing. And it's a preliminary step in this solution, but in general, the assumption is the controller and the thing has a pre-established, let's say, security association. So assuming that for any kind of SDN-based application, one specific application is this one, so we assume the same. And then from that point, and having that registration process, then the controller can send information to the things to configure the security association. In particular, in this case one, our assumption is that the thing have ad hoc and OSCORE implementation. So using, let's say here, the key management system, actually the terminology northbound interface is an interface that allows to talk with the controller to tell or to specify general security protection policies. That with that information, the controller with that security protection policy will transfer that in an ad hoc configuration, and that configuration will be sent through the southbound interface, which is step 3, to the thing A and thing B. Actually, we wrote there core conf because all the configuration is expressed in a Jan data model, and that data model is transferred finally in CBOR information that is sent using COAP in the southbound interface. So the southbound interface here is core conf, complete core conf. So when we send that ad hoc configuration to thing A and thing B, then they can establish the security association and protect the communication between them. But the initial configuration, as I said, is performed by the controller. Even during the life cycle of the things, that configuration may change or may include new things in the scenario, and so can be dynamically, let's say, configured during all the life cycle of the things. This is actually the case 1, and we have also the case 2. Assuming that the ad hoc is not in the thing, implemented in the thing, so only OSCORE, and the idea is the same, but now the configuration for OSCORE is expressed as well in a Jan data model, and we send the OSCORE context to the thing A and thing B to protect communication between both things. I think, okay. So the difference between this case and the case 1 is that here we don't assume that we have ad hoc in the things implemented. So directly the controller send all OSCORE context to establish the secure communication based on OSCORE. And this is just a tree with an example of the Jan data model related with ad hoc. So there is a block about specifying credentials, which is the auth entry. So identifiers and authentication methods, and if some private key is required, etc. And then the definition of a connection is the connection information between two things. It can be the local, I mean the thing that can have a resource that wants to protect, but can also access another resource in another different thing that wants to access securely. So that's the connection information. And then finally, a block related with policies. We have used something that is used typically in IPsec and adapt that to this model, which is the policies based on bypass, protect, or discard, depending on the resource actually a thing wants to access. So maybe there is no need for protection, or actually is filtered out. So a thing cannot access a particular resource in another thing, or can be protected. And the information to be protected is specified in the target and the logger resource. Target resource in the case the thing A wants to contact to thing B, and the thing A needs to protect their own resources, will use the local resource information. So basically, this is the general view of the Jan data model ad hoc. And similarly, we have the OSCOR. Obviously, it's simpler. And here, actually, what you can see in the model is just go to the RFC and see what are the parameters are required to define the OSCOR context to be sent to a particular thing. Obviously, you need to send a context to the thing A, a thing B. And we have extended that with the policies as well. So in case we want to access a particular resource and needs to be protected, that will be OSCOR protection, and all the information is actually in the first block, which is the OSCOR context. So this is actually the Jan data model for OSCOR. And actually, this is an example. We use XML, but in the real truth, we are using it for our implementation PyCon-Conf. And with this information, this is the expression of the Jan data model in XML, but can be expressed in JSON and from JSON to CBOR, and transported that CBOR information using co-op. We can configure actually the thing A and thing 2. Here it is represented like T1 and T2. This is the example with the doc. And we set the credentials and the resources we want to access, and we want to access with protection, of course. And we provide all the ad hoc information we need to establish the ad hoc security association. And this is a similar example with OSCOR. Actually, here we need to send the master key, master salt, and the algorithms and everything, because there's no negotiation with the doc, just to set the context and allow the thing, the T1 and T2 to connect each other using OSCOR. And next slide. Here we have now proof of concept. Actually, we haven't implemented that in constrained devices yet. This proof of concept is based on a Docker scenario with multiple Linux nodes. So, and nodes that receive ad hoc OSCOR configuration from the controller. So controller is another container in Docker. Can be on demand or once they are all registered. So like a reactive or proactive execution. The registration right now has been implemented using a co-op request from the thing to the controller. So once the thing comes up, sends a co-op request to a resource in the controller saying I'm here. Obviously, the assumption is that will be authenticated, and then the controller is registered. The thing is registered in the controller. And after that, the controller can send that information to the node. We have deployed 2 topologies. One of them is star, like a central node, and then another around, and then the mesh topologies, just to test the implementation. We have focused our implementation the southbound. It means that we need the core conf. And actually, for transporting the information we required that is in CBOR, we use the Jan to CBOR library, PyCon-Conf from IMT. And we are using IO co-op to use co-op implementation to send that CBOR Jan data model transformation to the things. And that southbound, actually, between the controller and the thing, using IO co-op can be protected using the OSCOR as well. Obviously, this is different because the keys are manually set between the controller and the thing, assuming a dynamic or autonomous registration process or onboarding process. That key will be generated during that process, but here is just manually set. And for the communication between the things, we're using MicroDoc, MicroScore implementation. We had the opportunity to talk with the main developer, Stefan, in Paris during the meeting. So that is our proof of concept, and we are deploying both topologies, star and mesh, and trying to get some performance results. This is actually the case one. This is the mesh, the most complex one. In order to test how many, let's say, security association can configure the controller. And this is also the mesh scenario is the same, but here the information is just the OSCORE context to protect communication. And finally, as a next steps, our idea is to continue with extending the Gen data models to include some additional extension to OSCORE. Right now, what we have modeled is just the OSCORE context, but there are a lot of extensions like kudos or group communication, etc. I also talk about this with Marco in Paris. So it's just to extend the Gen data model with the group communication stuff. It could be also possible to distribute the pre-shared key between the controller in the case one, when if we have the ad hoc PSK based authentication. And we could add new protocols, not only ad hoc or SCORE, but also, for example, DTLS in case it is required. As I said, our idea using this proof of concept is to take some measurements and transport. Another obvious idea is to transforming this virtualized scenario to a real scenario with real devices and see how it behaves. And one problem we may have, obviously, is that right now the Gen data model are experimental, and we should need a place to define and to discuss those Gen data models that actually are modeling ad hoc and OSCORE. So if this idea evolves, that would be our idea. What we don't know is the place to do this, if there's any place to standardize this kind of Gen data models related with ad hoc and OSCORE. And that's all. I haven't followed the chat.
Yeah, I think, first of all, thank you for giving this talk. I think one thing that people tend to knee-jerk on is sending private keys over the wire. You usually don't want to do this, but the reasons why you don't want to do this are a bit more complicated than the simplistic rule I just stated. So generally, it's really useful to send authorization information from a controller to a device. When it comes to authentication information, the problem, of course, is that the device needs to have something like an initial identifier that can be used to send something to it. So you need to bootstrap this in some way. And people who look at this think this is meant to do the bootstrapping. And I think you are not using this for bootstrapping. You are using this for putting in the operational configuration. Is that true?
Yeah, the thing is, the bootstrapping I mentioned is to establish the trust between the thing and the controller. After that, the controller became a key distribution center, a trustable key distribution center.
Right.
In terms looking at the key distribution, okay. So in that sense, the controller is a trustable entity that is able to distribute that key material. The most, let's say, in the OSCORE case, where we have OSCORE only, obviously you're setting the symmetric keys you need to protect the communication between things. But as I said, that controller is a trustable entity because there is a mutual authentication during the registration. So the thing trusts on the controller, and the controller trusts on the thing.
Right.
And obviously, if that case 2 might be scary at some point, you have ad hoc. You don't need to send the private key. Actually, during the registration, the thing can send their public key, and then that public key can be, let's say, like certified somehow. So, but potentially the controller, and I agree with you, can send that information to the thing. But to me, it's very important to understand that the controller is a trustable key distribution center after the registration. So it's
the main point you just made is that we already have mutual authentication in place before we actually start using your model.
Yes, between the thing and the controller only.
Yeah.
Because actually, but that is something that happens in any centralized solution to configure critical information. If you don't trust in the configurer, then you have a problem.
Certainly.
So the assumption, of course, in any SDN scenario or any centralized scenario is that you have a trust on that third party that is distributing that critical information.
Yeah, one important observation is that trust is a liability. If somebody trusts you, you have to make sure that you earn this trust, or you will create trouble for that somebody who trusts you. Christian is in the queue. Maybe he can elaborate on that.
No, I'm in the queue for an independent point.
Okay. Good. So the point is, it's nice to be trusted, but it's also a liability, and I think we pay much too little attention to liability issues in IoT systems. People who manufacture large quantities of something are really interested in controlling their liabilities, and I think a liability consideration section should be needed for any kind of IoT.
Yeah, that's right. But in my mind, since you have, as I said, that initial process where you authenticate and authorize actually that during the onboarding or bootstrapping process between the thing and the controller, and you establish that in that moment you create all you need to what is necessary for that trust you mentioned. So I think obviously that part is critical, not only with this solution, but any other solution. Actually, this discussion already also happened during the standardization of the SDN and IPsec and IKE, the same thing. And the conclusion, obviously, we added in the security consideration all the key distributions aspects, taking into account the controller has the power to send that context to the things. In that case, in the IPsec was the routers and everything, but actually in the draft we inherit the same security consideration from the RFC we wrote related with IPsec and IKE, so people have a clear picture about it.
Thank you. Christian?
Yeah, Christian, I'm just, please consider whether some of the modeling that you're doing here can be shared between ACE and here. I see an expression of AEID algorithm and master key there that you may not even want to manipulate individually anyway, because that opens up for other things. So those things have already been expressed in ACE, for example, from the confirmation claims for CWTs. So please look into whether there can be some deduplication between those modelings, rather than building a separate tree of, it's like in ACE we have an ACE Oscar profile and an ACE ad hoc profile, and now you consider like adding DTLS here when there is already ACE work for expressing DTLS keys. So I think there can be deduplication by looking at what has been done there. And this goes in both directions. This simplifies things here. And if it turns out that, for example, AIF is not suitable for the scopes you're expressing here, then what you're doing here might also be useful for people in the CWT space to express their scopes.
Mhm. Actually, regarding your comment, actually, obviously the Jan data model can give you the flexibility to include any information you want, or even a token if you need that. Actually, in the figures we show, there are like two communication between the controller and the things, but actually you may send only configuration information to one thing. That's something that's required to that thing to contact with the thing. For example, from thing A, you send configuration from thing A, but you don't need to contact with thing B because you have already sent any token or anything to thing A to contact to thing B. That is also possible and can be extended. And another additional comment, general comment, is that if you look at the all score, and they mention, as far as I remember, some kind of or any other protocol like out of band mechanism to provide a pre-shared key, for example, or key material. Actually, this is a solution for that out of band mechanism based on a model based on SDN. Okay. So just a final comment from my side.
Laurent, can you be quick?
Yes, I will try. Can you go back to the young data model, please, Rafa? Because one point we discover when we create the young data model is that we use at the beginning X string instead of binary, but when you do the conversion in CBOR, it becomes a string, and so it's not very efficient. And I think it's the same for date, for IP address. So maybe it will be nice to have an extension to the CBOR mapping and convert these element in binary directly.
Yes.
There is work going on for doing stand-ins using binary CBOR tags for things that normally are text in Yang. So if that goes through, we may have a solution for that part.
Okay, perfect.
Good. So thank you, Rafa. I think
Thank you.
The point that Christian brought up, that we probably need to do a sweep over our various models that try to do almost the same thing and find out whether we can factor out some common material. I think that's a pretty important point, and I think that's actually the subject of a very nice survey paper if we get to this.
Okay. Thank you.
So we are already a little bit late. Sorry about that, Manoj. So some of your points already came up, but I'm afraid you only have 22 minutes left now. So I'm trying to bring up your slides. Something weird happened again. But you can always start talking.
Okay. Thank you for sharing that, Carsten. And I think hello everyone as well. I am not sure how do I change the slide. Okay.
You have control now.
Okay, perfect. Got it. So again, hello everyone. Thank you for joining, and thank you Laurent and Alex as well, because I think I'm going to use some of the concepts which they have shared today, especially about Yang and Sid. And this is more. This is not a tutorial. This talk. This is more of a talk about how do we actually build applications for using CoreConf for our own for our own requirements. So that's the main objective. Okay, so I think two things which we need to be like extra clear. So CoreConf is an representation format when we are talking in context of this sort of session, and then there is a serialization format which can be CBOR or JSON. So CoreConf can be serialized into CBOR mainly, but it can also be serialized into an equivalent JSON, which is not defined but can be done. Okay, so about the architecture. So let's assume that you have a well-defined architecture. So you have either a client-server model, or you have to build an embedded system. And in that embedded system, you plan to exchange or interchange data using core conf format. Right now, you are doing it using a JSON data, and the JSON data has a model, or it has at least some structure which is well defined, and on the wire, the data which is being exchanged is again in JSON. So this is what this is what this cycle looks like. So you first is design your Yang model, then you generate sets on them and register, then you implement C prototypes, which we'll get into what they are and how do we go about it. Then you generate a CBORD dump of your data model, and then you programming into Riot, which is the target RTOS, which we are using it here. And then this should take about 0 minutes, because we all know it can be auto-generated. So this is just a joke. Again, this is just to be provocative. But anyway, so going on. So first, I'll quickly go through what won't go into the detail, because I think most of the concepts is already sort of explained by Laurent before. So I'm going to pick up the same example which he used, which is how do we define, or rather, how do we actually describe your data structure using a Yang model? So he did mention a lot of identifiers. He did mention a lot of things. The interesting part where you talk about the relationships is in the container part mainly. So from his example, you can see the container part on the right. So you see sensor object, and then there are leaf nodes, which are basically which have a particular type. These types can be a regular enum type, unsigned integer, etc., which is I think well defined. So equivalent tree structure looks like this. There are some it can have list as well, and that list has to be defined or sort of identified uniquely by its index or some sort of a key, which we call it as a SID key. Going forward, then once you have this well-defined Yang model, what we do is first we check if there are sets in the registry already, but if not, you actually generate them, right? So how do we generate them? I think that has also been talked about previously using Pyang tool, and I would like to thank them, because I think I used a lot of their work and sort of reused their tool a lot. And if you think these identifiers are common, and your identifiers or your sets can be reused by others, I think it's a good idea to register or sort of publish them as well. Okay, now the interesting part. So again, I understand it's been a long day, so I'm not going to go into the code in detail, but I'll just talk about how the prototypes or how the stubs should look like. So we want to auto-generate most of the work which we or sort of generate code for our model as much as possible, so that we don't have to type it manually. How do we do it? So there is this tool which is included with the C core conf library. Is this the best place to keep it? We can debate on that. But what it needs, it's called generate stubs, but it's a small Python script. All it takes is a SID identifier file. Once you give it a SID identifier file, then it will actually generate a header file and an associated C implementation file. Let's see that. So once I do this on the SIDs generated on the previous example, it should look something like this. So this is what the header file should look like. Most of the header file are like aliases or like synonyms or whatever shortcuts which we can use. One of the reasons for generating these prototypes is also to not having to remember the SID of each of your leaf or each of the implementation which you want to do. So the header files basically contain function prototypes. Why is there a requirement for key mapping? We'll get to that in a bit. But mainly the header files is 3 components: aliases, encoded key mapping, and then the function prototype. The implementation part or the implementation file contains is slightly smarter in that it infers the data structure, or it sort of understands that to reach a particular leaf, you need to go through a particular SID, and it automatically builds a prototype according to that. For example, if we go to the previous tree, which is which is here. To select a particular sensor value, you need to go through the index, because only then you will be able to uniquely identify which element or which subtree you are looking for. So going back here, yeah. So to get a particular sensor value, you need to define, or you need to have a particular index, and the types are already inferred from the SID files. And then there is auto-generated stubs for the other leaves, which do not have much information about it. So we put it as void. But again, we can improve based on that. Then we generate the seaboard dump of our model. So this looks something like this, which is again a short Python file. What you have to do is give it a sensor instance of your JSON. Now, in fact, I think we have it somewhere here. Yeah. So you're on the wire right now. This is the information which goes on your left-hand side, which is a JSON serialized data. And so this is the one which we pass to this tool, and then we also pass the SID file, which has been generated before, and then we tell the name of the header file where we want to dump all this data. And what it does is it actually takes this instance file, converts it into a SID represented coreconf format, and this is done using PyCoreConf, and I think Alex is here who sort of built that tool. So this is again then dumped into CBOR, and this dump is basically a uint unsigned integer 8-bit array, which is dumped into the CBOR header file, which will be used by the library later. So going forward, and then we actually sort of push it into the Riot, and this can be used to actually traverse a tree to actually look up a particular key, or to look up a particular leaf using a particular key. So this is an example where the C coreconf library has been integrated into a Riot application, and what we try to do is basically have a host on the left-hand side. So this host can be your server, and an embedded device, which is running RiotOS, and this RiotOS is using the C coreconf library to exchange and interchange the data in coreconf format. This embedded device does require the data model, which we talked about, which has been dumped into a CBOR serialized unsigned integer of 8-bit array, and it also requires it also implements a sensor mechanism. So basically, this is a function which we implemented by generating the prototypes. Let me see if I can actually share my screen. Okay. Carsten, can you allow me to share my screen?
I'm trying to find out which button I have to press. I'm sorry.
Okay. No worries. If it is too difficult, then it's fine. We can just continue, and I have a screenshot. I can just show that instead.
I used to know how to do that, but I'm sorry, Ari, do you know what to do here?
No, I was looking for it. Can you request it again?
Okay.
Here we are. Yeah, okay. You have to go to the queue, and in the queue you can grant the screen.
Okay, it says all the slots for requested media are already taken.
So you have to stop the slide sharing.
Okay. You know what? Maybe never mind. Maybe we can do it later. I'll just continue with the slideshow. Okay. So we'll look at a screenshot of a RiotOS running, and I'll talk about it. But what are we trying to do? So what are we trying to do is basically request two things. So one is, give me the entire tree corresponding to the SID 6005. And this request number two is, give me the subtree of SID 6007 or 60007, where the SID key value is 0. Okay, so that's it. That is what it looks like. I have written it in a more legible form, which is, give me the subtree where the SID key is 60007 and the value of the SID key is 1. Okay, it has to be 1 here. Sorry, I messed this up. But anyway, by the way, somebody asked that, okay, what format is this for requesting? So I think this format conforms to the IETF core COMI 16. So this is where the fetch request is sort of defined, and we are just doing a fetch request using CoAP on that. So you do that. Okay, so this is what you will see. So you see Riot emulated server on the right side, which is basically an example of a CoAP server running. And then what you do is a client sending the payload. Once you do that, once you do a request, what happens is it will search the particular tree, and then it will return a response which is in CBOR as well. So you see 60,000 for 60,005, you see the entire tree here. For 60,007, you see the entire information here for the particular key where the value is 0. So 60,000 0, so 60,000 0, and yeah, we are able to get the response correctly. Okay, then the question is, in real life, what has been, or where has it been used? So in real life, it has been used for a small experiment, balloon experiment, led by Professor Didier Donces from University of Grenoble-Alpes. The platform which they used is IM800B, which is a LoRa model, LoRa-enabled module, and we actually flashed it with the Riot operating system, which was integrated with CoreConf, and it was we were able to sort of query temperature sensor data from it and plot it on our server side, and then see that we are able to sort of query as well as exchange data with it correctly. And more or less, I think if you want to contribute, where would you want to contribute? So then it would be the engineering work. So there is a lot of engineering work to be done here as well. So profiling this library, integration with Zephyr and other operating systems. There is security consideration to be sort of researched and understood, because I think the library we did not actually consider that, so it cannot be used for production directly. Then there is scientific work to be done as well. Like, okay, what if your model changes, Yang model changes? How do we actually go through this, and sort of flash your device correctly, and like to sort of update the device without a lot of modification? Then I think Laurent mentioned it briefly, which is lightweight M2M or SenML integration. So if you have that, can you use this library without modifying too many parts of your stack? And then there are other links. If you want to use the library, you can use it. It's available. There is a Riot integrated example here as well. You can click on the example, you can clone it, you can build it, and you can see this whole example which I showed without having to understand what the library is. Then I have also written, if you are insomniac and you're not able to sleep, you can read my master's thesis as well on this. It'll put you to sleep for a good 8 hours or maybe more. And yeah, that's it. Thank you so much, and I would be happy to answer any questions you have.
Thank you. Questions? While we're waiting for questions, I just have one comment on slide 16.
Okay.
So looking at the slide, it's really hard to find out what's going on in this CBOR dump on the right. And we have this convention of using pretty printed hex dumps for showing CBOR data. So you would see that the A1 actually is a map, and the 19EA65 is the number 60,005, and so on. So that's really useful, and it's often also useful to use diagnostic notation. So what's in the middle column of this slide actually is diagnostic notation, if I see this correctly.
Yeah, correct.
Okay.
Yeah, thank you for that. I'll make it more clear next time.
Yeah, that was just a comment, but do we have questions? Harry.
Thanks. This is very interesting. I mean, maybe it's a bit of a detail, but this topic of SNML integration has now come across twice already. Can you elaborate a bit more on your thinking? What could be done there?
Yeah, sure. In fact, okay, I don't have a slide here. So basically, what I was able to do is SendML also has a JSON instance. Typically, it is exchanged. The data is exchanged on JSON on the wire. So if you can create a YANG model for your SendML data, then you can follow the whole stream. So this whole presentation is basically streamlining application of CoreConf on your embedded devices. If your embedded device does use SendML, you can design your YANG model around it to be specific to your data model. Generate sets locally, at least for now. Implement it in CSUBs, generate your seaborn model, and then program it on the right. So what you will see is a very compressed CoreConf format on the wire for your application. And second is if your server side, you can't actually change too many stuff. So what you can do is add an additional proxy layer so that it can convert from this CoreConf into an equivalent SendML data, SendML data instance, which can be understood by your server. So that is what we were thinking. So on the wire it will be CoreConf, but on the other sides it will be SendML. That is what we were investigating during my master's.
Okay, great. Thanks.
Thank you.
Any other questions? Thank you. So my summary would be that we have got a pretty good view of what people are doing with CoreConf at the moment, and it's definitely important, in particular since we still have to complete the CoreConf specification over in the IETF. It's good to know what people are using it for. What we didn't talk about is that CoreConf had some simplifications applied to it recently, and not all of these simplifications have found their way into the implementations that people have. So there's a little bit of implementation work to do there as well. But the most important thing is to make sure that CoreConf, as standardized, as specified, actually works with the various prototypes and proof of concept implementations that we are doing. Manuel.
Yeah, I agree with that. Yeah. So again, there are a lot of one comment is like the sooner we sort of standardize, the better it is. But it's also important to actually put it into industry so that there is a feedback loop which comes and like it sort of either validates the theory or like sort of finds the gap in the theory which we can fix. So I think we had several gaps when we were building this library in the theory itself, which I won't go into, but sort of. Yeah, we the sooner we start using it, the better, or like the sooner we can complete on the theoretical aspect as well.
Yeah, so if you have input to the standardization part, that's what the core working group is for. That's what the core mailing list is for. So any input is very, very welcome, because we will be finishing this up very soon.
Noted. Thank you.
Okay, so we have seem to have gone to the end of our 2-hour slot. This agenda was, how shall I put it, pretty agile. So I think we made pretty good use of our time. And we will meet in slightly more than 2 weeks for the next interim, if you are interested. Thank you very much. See you later.
Great. Thank you, everyone.
Bye.
Thank you.